You have learned that using a structure helps you organize your data and functionalities. Instead of having fragmented data and functionality throughout your code, a structure helps you package them into a single instance. At Little Lemon Restaurant, the menu app has an extensive list of offerings including food, drinks, and desserts. The common thread between these offerings is that they all have recipe ingredients. The recipe ingredients allow the staff to understand the ingredients necessary to prepare the menu items, and the customers can view the ingredients to check for any allergens. In addition to the ingredients, each recipe has a name and steps to make the dish. In this video, I'll create a recipe structure to encapsulate recipe-related data and functionalities. Let's begin. First, I define a recipe structure instance by typing the struct keyword followed by recipe and curly braces. Recipe is the identifier of the structure. Next, I need to add properties and methods to encapsulate the relevant data and functionalities inside the structure. The properties and methods are added to the structure definition between the curly braces. The first property I'll add to the recipe structure is for the name of the recipe. Inside the structure definition, I declare a constant called nameOfTypeString. The second property I'll add to the recipe structure is the ingredients for the recipe. Inside the structure definition, I declare a variable called ingredients_of_type set of strings. I choose to use a set here because the ordering of the ingredients does not matter. I also deliberately set the ingredients property as a variable to allow the property to be altered after initialization. The third property I'll add to the recipe structure is the steps for making the recipe. Inside the structure definition, I declare a variable called steps_of_type_string_array. I choose to use an array here because the ordering of the steps does matter. I also deliberately set the steps property as a variable to allow the property to be altered after initialization. Now, to conveniently display the properties inside a recipe, I'll create a method to print the recipe name, ingredients, and step-by-step instructions. Inside the recipe structure definition, I add a method called printDescription. In the body of the method, I print recipe: string interpolation of name. In the next line, I print ingredients: string interpolation of ingredients. Then I enter a new line and use the enumerated method on the steps property to loop through the steps while getting access to the current index and step value. At each iteration, I print string interpolation of current index +1 followed by a period and a space. Then to complete the print statement, I add a string interpolation of step followed by a period. I am adding a 1 to the index because the index starts at 0 and I want the step counts to intuitively start reading at 1. At this point, I have defined a recipe structure with 3 properties and a method. This is an example of encapsulating data and functionalities inside a structure. Now, I'll demonstrate how to initialize a structure instance. To initialize a recipe structure instance, I'll simply need to type recipe followed by an open parenthesis, pass in the parameter values into the initializer method, then add a close parenthesis. For the name parameter, I enter chocolate cookie. For the ingredients, I enter cocoa powder, chocolate chip, and flour. For the steps, I entered first action, second action, third action. Now I assign the struct instance to a chocolate cookie recipe constant. At this point, I have initialized a structure instance and assigned it to a constant. Now I can use the printDescription method to conveniently read the data of the chocolate cookie recipe. In a new line, I type chocolate cookie recipe followed by the dot syntax and the printDescription method. When I run the code, the console logs the recipe name, ingredients, and steps. By completing this video, you should now be more comfortable with defining and initializing your own structures to better communicate the intent of your code, to organize your code, and to make your programs more expressive.